All right, guys, back for part 2. We're going to convert polar equations to rectangular form. So these are the 4 formulas, basically, that we have used so far in this unit on this page and the previous page. You're going to basically be choosing between these to use down here as well. So the first one is r equals 2. The only one we can even use completely is going to be the first one. X squared plus y squared is equal to r squared. And that's going to look like x squared plus y squared is equal to 2 squared, which is 4. This is the formula for a circle, because it would end up being x squared over 4 plus y squared over 4 is equal to, 4, or 1 in that case, to put it in that formula. But we can leave it just like this. And if you were to graph this into Desmos, you would also find that it's a circle. The radius is 2. So from the origin, it radiates out 2 units. And basically just that is where the circle is located. So this is A. All right, for B, we have theta is equal to pi over 3. So for this one, we're actually going to use tangent. Tangent theta is equal to y over x. So tangent pi over 3 is equal to square root of 3. And you can look at your unit circle for that, but I have it right above. So then we're going to place that with y over x is equal to square root of 3. So since tangent theta is equal to y over x, and y over x is the square root of 3, I've just gone ahead and set those equal to each other. Now I'm going to multiply both sides by x and move it to this side. So now it looks like y is equal to the square root of 3 times x. And that is a linear equation. And this is how you would graph it. All right. For this specific one, I would find where tangent is equal to the square root of 3, which is going to be here. And I'm just going to draw a line. And that's B. All right. This is the location of pi over 3, if anybody was confused where I got that from. All right, our next one, rectangular to polar. So they're giving us that x squared plus y squared is equal to 4. Now we're taking the equation that they've given us and putting it in polar form, which we know is obviously this one here. But we know that r squared is equal to 4. That means that r is equal to 2. So we're going backwards now. And again, this is a circle. It's the same circle that we already graphed. But we'll go ahead and graph it down here again. And I don't think we'll be graphing this one here. No, we will not. So x is equal to 10. So the only thing we're going to use is our x is equal to r cosine theta. 10 is equal to r cosine theta. We're going to set this equal to r. So I'm going to divide by cosine theta, divide by cosine theta, and r is equal to 10 over cosine theta. I was thinking for a second. Sorry about that. And just to make this look a little bit nicer, we'll do r is equal to 10 secant theta. So we won't be graphing that. We're going to be leaving that as is. All right. Now, this one's going to be a little lengthier. I'm basically going to break down number 1, and I'm going to fill out number 2, but I'm not going to go through the steps of all because it will just take me a super long time, and the concept, again, is pretty easy. So the first one is to graph r is equal to 3 sine 2 theta. Sine 2 theta. You should remember this from your Pythagorean identities sheet. When we write this out, it would be r is equal to 3 times 2 sine theta cosine theta. All right, and I'm going to break down just a couple of examples for you. So I went ahead and filled out these theta measures. You should do the same. We're not even going to be able to touch all of everything that we're going to be plotting, but I'll still be showing you how to plot all of it. So when we fill this out, we'll use this one up here. 3 times 2 sine of 0 cosine of 0. All right, when you do that, from 0, we would have 3 times 2, which is 6, times 0, 0 times 1, 0. So anything times 0 is going to be 0. And that means that our measure is 0, 0, because our r, which we just found, is 0, and the measure that we were using is 0. So that's going to be a point that we plot, which is the origin. All right, so again, I'm not going to go through all of these because it will take a super duper amount of time. But what you can do is put them into Desmos and get decimal answers. I'm going to go ahead and fill out what they'll be once you put them into Desmos. So we have approximately 2.63. Let's do the square root of 6 together right quick. I'm going to show you how it looks in decimal form from their square root form. So we have 6, well, 2 times 3, which is 6. So we've just went ahead and multiplied the 2 times 3. That just makes it easier. Times sine of pi over 6, cosine pi over 6. This is how it would look if you were to actually work out each individual one. All right, from here, we would find 6 times sine of pi over 6, which is 1/2, cosine of pi over 6, which is the square root of 3 over 2. Then we would end up with 6 square roots of 3 over 4. And that would give us 3 square roots of 3 over 2 when simplified. So this 3 square roots of 3 over 2 is 2.6. All right, so that is how you do it. But if I just highly recommend putting into the calculator just to make it a little bit easier. This one is also 2.6. This one's going to be 0. This one is negative 2.6. We've got a negative 3, negative 2.6 again, 0. And this one is repeating pretty readily here. Then we have 2.6 again, negative 2.6, because we've skipped quite a few here. I just wanted to give you an idea of what it's going to look like. All right, so I'm going to go ahead and plot some of these and write them how they're going to look. So the R goes in the front, and then the theta is the second, which is the Y. So it would be 0.027 pi over 12. 2.6 pi over 6. And since we just went through plotting these in the beginning, you should know how to. Pi over 4, 2.6, comma, pi over 3, and so forth. Again, this is just a very lengthy amount of steps, but it's pretty much repeating the same thing over and over. Negative 2.6, 5 pi over 6, and so forth. 0, comma, pi. I feel like I should stop, but I don't want to just like leave it unfinished. Negative 2 pi over 6, 5 pi over 4, and last one, 2.6, 4 pi over 3. All right. Ooh, now that that's done, we can graph. And again, I'm just going to fill this out later, and you guys can refer to it or check it if you want to see how you do on your own down here. You're more than welcome to do that. I'm basically just going through this first one here. So 0, 0, and then we have pi over 12.027, which is going to be just, like right here. I'm just gonna connect these as we go. 2.pi/6, 2.6, which is gonna be somewhere around here. Typically you should be connecting these as you go, but I'm just gonna wait just so I can kind of make sure I'm doing it correctly. Pi/4 is 3. 1, 2, 3. Pi/3, 2.6. Okay, so I want to make sure that these are pretty even here. Pi/2, 0. Okay, so this one looks like that here. And as we've kind of already seen, I'm pretty sure this is just going to repeat itself. All right, where were we? We're getting through that pretty quickly. We're already to 2 pi/3 at -2, 6. Oh wait, positive 2.6. 1, 2.6. I'm guessing 3 pi/4 is going to be 3, which it is. All right, and then we've got another 2.6 here. And that's going to end up looking like that. It's going to be the same thing. I already know it's going to repeat, so I'm just going to go ahead and make it look that way. And is 7 pi/4? We didn't put it on here. That's okay. It should be 3. And that's how it's going to end up looking. I'm actually going to check one of these because it looks like it should be, let's see, 3 pi/4 would be 6. 3 pi/4 is -3. Well, 7 pi/4 will be -3. Okay. Well, either way, it's going to end up looking just like this one here. All right, so this is going to be the first one. So one thing you'll notice, and I just noticed it as well, is that at 3 pi/4, our answer is actually -3, which is this dot here. But 7 pi/4 would give us -3 as well, which puts us over here. So that's why I'm not too worried about it. Again, it's just easier if you plug that into Desmos and get those points and then write your coordinates. This is going to be the easiest way to graph anything here. So, and you'll do the same thing down here. And again, I'm going to work this out and probably just, it'll be in the Padlet for you guys to look at and double check if you would like to. All right, and this pretty much all on polars.